Okay, Electrical 2 Test 8. Which of the following statements is true? Oh, I know what I was going to do. I was going to get another one of them pigments, but I'm okay now.
Is it electrical or is it performance?
Electrical 2. Electrical 2 Test 8.
Okay.
Which of the following statements is true concerning headlight circuits? A, the circuits can have totally insulated bulbs and grounded switches. All lamp filaments are connected in parallel. Some circuits are lamps that contain a high beam and a low beam. Or all of the above. That's all of the above. But some of these vehicles, like the Cadillac we worked on the other day. Oh, by the way, up here is another job that I forgot about. We got to put 2 tires on front of that Cadillac. Somebody does. Anyway, that's not a big deal. We'll make it happen. But anyway, that Cadillac, remember, has got different fuse for each headlight. You know what I mean? And a lot of times you do that. Why would they do that? Why do they make a different fuse for each headlight? If some of them blow, if some of them pops a fuse, you still got the other headlight. Another thing they do is they put circuit breakers that are resetting, and they're inside the headlight switch. There was a headlight switch laying up here a couple of days ago, right here. This kind of headlight switch here, that you see right here, has got an internal circuit breaker. And if one day you may get a job where there's a car that's the lights, when you turn on the lights and leave them on for a while, they start going ding, 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 cutting off and on. That's going to be the circuit breaker inside the headlight switch. You're going to look at your schematic, you're going to see that it's got a circuit breaker built inside the headlight switch. They're nice about drawing that. So keep that in mind. And that's on these old kind. It's got your pull knob to turn on the lights, you know, basically. The tail lights of a vehicle are dimly illuminated when the brake lights are on. Technician A says this could be caused by a blown fuse. Technician B says an open ground circuit could be the problem. Either one. Let me ask you this, and I mentioned this before, I think, in another class. What if I mashed the brakes and my dash lights come on? Remember what that was? Remember me talking about that? Anybody remember that? I mashed the brakes and my dash lights come on. And you might not notice it unless you're sitting in the shade. So you got a short, but where is the short? Where's the most likely cause of the short if I mash the brakes and the park lights and the dash lights come on? It's a bad bulb in the back. Take all the bulbs out, mash the brakes. If it still comes on, you got wiring problem. If you take the bulbs out and it goes off, one of your bulbs is bad. Touching on the inside. It's going to be what it is on there. Which of the following lamp designs have the fastest activation time? Halogen, tungsten, neon, or halide? Anybody know? Let's try neon. Yeah. Did you know the headlights on the Dodge Neon lights up so fast? No, that's a neon light. All right. Technician A says composite headlights do not have replaceable bulbs. Technician B says composite headlights with broken lenses will continue to operate. And that's B. Composite headlights mean what? That's these plastic headlights that are on front of these vehicles now. They're always getting smoky. If you broke an old headlight, typically the bulb, the filament was exposed. But some of these old style flat front headlights that are glass, they've got a halogen capsule on the inside of them. And you can break those and the light will still burn. And so basically they're talking about if you just break the outside, the halogen bulb is still going to work if it's got a halogen capsule in it. And a halogen bulb is basically a little bulb that's got halogen gas pressurized in it, and that makes that filament burn a lot brighter. That's why they do that. Another thing you need to be careful about is if you don't touch the halogen bulb when you're putting it in there, or it will blow in short order because of the grease from your hands. If you scratch it, it can explode and get glass in your eyes because it's got gas pressure in it. You understand where I'm going? So be careful handling them little halogen lights, even if they're blown. You know, they can be kind of dangerous if it shatters and it's close enough to your eyes, it can get something in your eyes. So don't, be really careful with that. Number 5, to assist headlight aiming, most sealed beams use what? Number 5. Basically, that's going to be aiming pads. The sealed beam lenses, and also not only that, but you've got on a lot of your, not all of them, but on a lot of your headlight bulbs, you'll see 3 little things sticking out, and they're marked horizontal and vertical with a number. The center one on your aiming tool is always set to 0. Then you got the vertical and the horizontal one. Whenever you get it set up, then they're basically headlights. When you aim them, are supposed to be pointing straight ahead, and straight ahead and level. Is basically what you're trying to do. That's what that headlight aiming tool does. But how can your headlight aiming go awry if you don't know that you're on a level floor? You better do something to make sure you're on a level floor. If you don't have a headlight aiming, It's a little aggravating because nobody's usually got this much room, but if you get the car 25 feet from the wall and you know you got it parked perpendicular to the wall, you can basically, just pull it up to the wall and put an X with masking tape on the wall right in front of each headlight, and then back it straight up. It doesn't need to be this way or that way, and you can actually dim the lights in the shop or wherever you're at and adjust those lights until they're pointing at those two X's that you made on the wall, those two plus marks. And so that's the way you can do that. You can basically just point. It's got to be far enough away though that you can be accurate, because if you're right up on it, you're not going to be right. If you're back away from it, you can tell. Anybody ever run a spotlight? You ever notice how the teeniest little movement here makes a big difference down there? You just about the pulse in your thumb will just about make the light bump. I used to do that. And I always wondered how those people made them spotlights be so smooth, on Broadway and everything, but I could never make it happen. The bulb failure warning light of a vehicle is eliminated when the headlights are turned on. Technician A says this can be caused by an excessive voltage drop on the ground circuit of one of the headlights. Technician B says excessive resistance in a low beam left circuit could be cause the warning light to be on. Who's right about that? Both those guys are right, because when you got lamp out warning, you're basically going to be, what those lamp out warning things, it depends on a certain amount of current to be flowing through that bulb circuit. You got me? You understand what I'm saying here? All right. If you don't have a certain amount of current flowing through there, and and some of them are pretty sensitive. On the Jeeps, Grand Cherokees, they had this lamp out failure thing back in the 99, 2001, 2002 range. And I've actually had those things in there, and it would say rear lamp failure. Now that is one wire that's coming from a box behind the left tail light, and all of the lights are wired through that little box, and it's got a whole bunch of little shunts in there, and they're basically is measuring how much current is flowing out all those lights. And they calibrate that thing when they build it. They say, if everything's like it's supposed to be back there, then there's going to be pulling this much current, and if the deflection is off a little bit one way or another, then we're going to basically send a signal on this one wire up to the instrument cluster, to the message center, and we're going to say that a bulb's out. And so I'd look at this back of this thing and say, okay, turn on the lights. Well, they're fine. I hit the brakes, everything will be fine. And what I would find on some of them is, those little plug-in bulbs that are a little fatter and brighter, and like they go in your map lights and they go places like that. There are several different numbers of those. And if you put the wrong one back there, it may look just fine from the back, but it will cause that lamp out to be on. Those lamp out modules can,
like 5 watts and 3 watts.
Yeah, and they're basically, but looking at them, you can't tell. But what you do is you go get the one that the parts manual lists for that Jeep high mount stoplight, and when you put 3 of those in there, that message goes away. Now I've seen that more than once, but it'll smack you around if you ain't thinking clearly. You understand what I'm saying? All right, now. And it all depends on how sensitive that box is. One day on this Explorer, there was somebody that was wired up the lights. You know how these people pull the SUV behind their motorhome, and they want the lights on the SUV to fire up when you hit the brakes on the motorhome. And they took it to one of these truck outfitter places around here, or whatever it was, and they put they just kind of scotch locked in there, and did it that way. Well, what happened as a result of that is the lamp outage module, which on that particular Explorer, it was in the console down there. That doggone thing got so hot that it just about caught fire and burned out the inside. It didn't burn out the inside of the vehicle, but it burned the whole side of that box, and it stunk up the inside of the vehicle, and messed everything up like that. And so, how would you take care of that? The lamp outage module, the way they scotch locked in there, whenever they mashed the brake, the current going through there was back feeding around in that thing and causing trouble. And so they give it to me, and they says they still want to pull the vehicle behind the motorhome, but they want you to fix it so that this won't happen again. Well, I had to put that lamp outage module in there, replace it, get everything else working like it was supposed to. And then basically I came up with a way to make that work so they would never have that trouble again. And the way that I did was, I got a long trailer, this wire that you use for wiring up a trailer, all right, and I ran it all the way back there to the lights. Like I did let's see, make sure I'm drawing where I can see. Okay, see, the lights were right here. I'm just drawing that real simply, and the stuff was coming to them. And I basically cut that right there. All right, and then what I did up here in the front was I ran those wires so that whenever they were going to use that trailer, I mean, they would basically plug in and they were bypassing everything on the vehicle and going right to those lights.
Mm-hmm.
But in order to make that work when when it wasn't hooked to the motorhome, I got a little jumper plug, which I made out of a trailer, connector, so that they could, when they plugged that in, then the lights would work normally. Now, granted, the current did have to go all the way to the front of the vehicle and come all the way back to get there. But see, when they pull that plug out and they plugged in their vehicle, their motorhome, now all of a sudden the thing was like a trailer, and everything else on the vehicle was isolated. That was something I came up with to make that work. I don't know what the right way to do it is, but that way worked, and they didn't burn anything else up. But a lot of times people will think they know enough about electrical stuff that I can just put me some Scotch locks here and everything will be aight. You know what I'm saying? Because they know how to make lights burn, but they don't think about what's going to happen down the road. And there was that one Thunderbird that they put Scotch locks on there, wired up the trailer, a little boat trailer, and drove it all night, and they burned the wire harness up on the car because the little 22 gauge wire wasn't sufficient to haul all them trailer lights, and it melted that wire all the way up through the, you'd think it'd blow a fuse, but it didn't. It melted the wire all the way up through the wiring harness, all the way across the top of the dash. It was a $3,000 repair because they used a Scotch lock to hook up a doggone trailer package. And that ain't the right way to do that on most of these new vehicles. All right, now then, let's see. Technician A says the poor ground on one of the headlamps will cause it to be dim. Technician B says AC generator output's too high can cause headlights to be brighter than normal. And that's C. It can also, if you're over about 15.5 volts, if it's charging way too much, it can blow those doggone halogen bulbs too, if it goes up too high. Let me see. Technician A says the headlight switch may be at fault when none of the external parking and headlights turn on. Technician B says it may be caused by a faulty circuit from battery to the switch. Who's right about that? Are you thinking about what they're saying here? Headlight switch may be at fault when none of the external parking and headlights turn on. Is that possible?
Yeah.
Okay. And technician B says it may be caused by a faulty circuit from the battery to the switch. That may be right, but let me hit you with this. Most headlight switches have got more than one power feed coming in. They got a power feed coming in that's going to drive the headlights, and they got another power feed coming in that's separate that's going to operate the tail lights. You got me? So your tail lights, and they've also got a power output to the tail lights, a power output to the dash lights. It's separate from that one, and then they've also got a power output to the headlights. Now, where does the power go when it leaves the headlight switch? Where does it go before it goes to the headlights? Anybody remember?
Say that again.
Where does the power go when it leaves your headlight switch? You turn on your headlight switch, it doesn't go straight to the headlights. Huh? Come on, guys. No. Don't play dumb with me. You guys aren't thinking clearly. It's got to go somewhere before it goes to the headlights. Dimmer switch, you guys. Duh. It's got to go to the dimmer switch, and then the dimmer switch is going to be how you select bright or dim. Got me? It's got to go through the dimmer switch on the way, right? That's like the ones that have the tail lights and the turn signals.
What about the ones that have two different bulbs for a low and a high?
Now, that's a little bit different, but still, think about it. You're turning all of those on.
And then it's got to go through that switch to find out.
Yeah, you still got to go through the dimmer switch is still in the loop. Now, I will tell you how a lot of them are wired up nowadays. The body computer, like for instance, on my 2000, I don't own one, but if I had a 2006 Impala, when I maxed the brake, I'm not feeding power to the brake lights. When I max the brake, I'm telling the body computer I've maxed the brake, and the body computer says, "Oh, you've maxed the brake? Fine. Now I'll turn on the brake lights." And I'll also release the shift interlock. The body computer's making the decision which lights to turn on. On these on the Jeeps, like I was talking about a while ago, if you pull the dimmer switch, you're not actually changing the position of the lights. You're sending a request to the body computer. The body computer is actually deciding to operate the relays that's going to change your lights. And besides all of that, the body computer sends a request to the instrument cluster. Look, we've changed from low to high beam. Could I please have a high beam indicator? You know what I mean? So we're talking about computers talking to each other, and you're just about a little switch with some resistors in it, and it's like a sensor. Your switch is like a sensor. That's why you're going to plug into your body computer with your scan tool, go in there and look, and you're going to see when I pull this thing, does it get a signal? If it don't, you either got a bad wire, or the connector's spread, or your switch is bad. Got me? So you're going to troubleshoot a lot of this stuff now with a scan tool that you used to use a test light for. Does this make sense? This is what we're in automotive electronics for. We're not in here to play tiddlywinks and sell you fried ice cream. What we're trying to do is remember this. All right. All right, so let's see. Okay, number 8. I wanted to qualify number 8 because that question was worded a little too simply. How is the 3-bulb taillight system wired? A 3-bulb taillight system. Yeah, meaning what? It's got a common brake turn signal bulb. It uses a separate bulb for turn signals, brake lights. All taillights are wired in series. It uses side markers that flash in the rear. That's going to be B. Separate bulb for turn signals and brake lights. Okay, let me ask you this. What if I mash the brakes on my car and nothing works except the high mount stoplight? You ever see that? Nothing works except the high mount stoplight. And I don't have the orange turn signals and the red, or maybe I do. But if all you got is there, typically, if you've got one that's got the same bulbs for the turn signals are the ones that give you your stoplights, that's going to be a bad multifunction switch, which would be your turn signal switch. Why is that? Because whenever you turn on your turn signals, whenever you mash your brake, the stoplight signal going to those lights that are going to give you turn signals goes through that multifunction switch on the way to those lights. If that multifunction switch goes south, and sometimes it'll be something as simple as they haven't used the hazard flashers enough to keep them from the contacts from oxidizing. Somebody turns on the hazard flashers and then turns them off. Now all of a sudden the inside of the switch is not working right. You got a high mount stoplight, but you don't have these anymore. And your turn signals may even still work, but you don't have stoplight. Always think about that multifunction switch when that happened. Now we had that on a 2006 Crown Victoria out here. We've been inspecting since it was a brand new car. And there were occasionally people talking about how sometimes the brake lights didn't work, but we could never duplicate that. When we finally found it, the ground right in the middle, pull the carpet back, and you found a ground that was loose and had been loose ever since that car was built. And that car had 200,000 miles on it. Wow. You know what I mean? But everything was so clean back there that usually you had a good enough ground where it light the lights, but occasionally it wouldn't work. And when I got a picture of it, the eyelets just never had scratched the paint. They didn't ever tighten it up when they built the car, And it went all those miles with most of the time the stoplight working. What happens if one doesn't, they don't work and somebody gets plowed into? But on that one, the high mount stoplight always worked. It had a different ground than those other ones. Okay, you need to be sharp and awake to catch all this stuff because I'm throwing you a lot of information here. Let me see. I'm going to turn this around. Technician A says the flasher uses a bimetallic strip to open and close the turn signal circuit. Well, most flashers don't anymore. Technician B says the dimmer switch is a part of the turn signal circuit. What was I just talking about? That's going to be, yeah. Well, the dimmer switch being what? What are you talking about? Basically, if I've got a multifunction switch, I'm going to say the dimmer switch is part of it, right? Because, I'm going to call that. If I'm pulling this stalk, this stalk does a whole lot of things. And nowadays, if you turn it to, turn on things, sometimes the cruise controls on it, and then, of course, you got one on the other side for your wiper. Some of you got your wipers over here. Some of you got headlights over here, all that stuff together. So that is a lousy question. The answer is supposed to be A, so put A, but I don't like the question. The right headlight does not function on either high or low beam. Technician A says this could be caused by an open ground on the right side. Technician B says the B plus to the dimmer switch might be open. Well, that's got to be A only because the dimmer switch, would affect both lights. That's right. Technician A says excessive resistance in the common portions of the circuit could cause both headlights to be dim. Technician B says the low AC generator output could be the cause of dim headlights. That's C. I will tell you on a Toyota Corolla, like if you got a 92 Toyota Corolla and one headlight is dim and the other one is normal, they're wired up to work that way if one of the headlight fuses blows. Out there under the hood, if you pull one of the fuses to the headlights, that headlight won't go all the way out, it'll just go dim, and the one on the other side will stay normal. And so if you've got a dim headlight on a Toyota Corolla or something that's Toyota about that year, just because that headlight's dim doesn't mean that the fuse ain't blown. And we used to have one of those here, and sometimes when I was going to plant a bug, I'd pull that fuse, and that for the right headlight or the left or whichever, and that headlight would go dim and the other one would stay on bright. And people would be scratching around looking for a ground and all this kind of stuff, Now, I didn't ever track down why it works that way. You know what I'm saying? But 'cause sometimes you just got to think, you know. And we had this Cadillac that came in there one day that this other mechanic was working on, and when he pulled the trigger to wash the windshield, the low washer fluid light would come on. When you go to wash the windshield, the low washer, and this thing was bright orange light. It was just in your face, bright when you pull that trigger. And so he checked, and it was full of washer fluid, and he didn't know what to do next. And so it was a Cadillac. We were at the Ford place, and the shop foreman was over there, and he says, "What do you suppose is wrong with this thing? It's full of washer fluid." And I said, "That washer fluid reservoir sensor is probably bad." He says, "But how do I know that?" And I said, "Because I just told you." And then he made him mad. But anyway, I said, "Look, think about this. Whoever built this Cadillac is not going to have it so that when your washer fluid gets low when you're halfway to San Antonio, that this bright light shines in your face and you got to find a picture of your girlfriend to put over it. They're going to make it where it only comes on when you're washing the windshield and it's low. That just only makes sense that they'd wire it up that way." And he was not really happy with my explanation, but whenever they put a sensor on there, it took care of the problem. You know what I mean? But if you have to think past what's on the surface, he was making it harder than it was. All right. Sometimes you just gotta, you know, in a situation like that, he was trying to troubleshoot it, and he heard relays clicking and all that. We didn't have a schematic, you know, just do what it makes sense. All right, let's see. 13, technician A says the flasher is at fault when turn signals work in one direction, but the indicator light stays on steadily in the other direction. This is old technology they're talking about right here. I don't know where they come from with this. Technician B says this condition may be caused by burned out light bulb. Who's right about that? That's basically, he says B. I will tell you that nowadays they blink faster. If you got a burned out bulb, you notice that. In my life, I got a bulb burned out on the left side. They go tiki 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 tiki. That's because that flasher is designed to know how much current's being pulled, and it's going to flash it quicker. You still got a turn signal, but it's just flashing faster, and it's giving you a flag. What if I turn on my park lights and I got a indicator light, a turn signal indicator light that comes on? You know what I mean?
On your headlights?
Yeah, like a park light. Turn on my park lights, and the turn signal indicator light comes on. You got me? Got a little trouble? What's going on out there? Can anybody see? Oh, Miss Goofy getting some coffee. Okay. I thought I smelled something. There's Joe. All right then. So
I don't know.
that's typically going to be a ground problem. I mean, usually that's going to be a problem with a bad ground. Now, where do you usually find a bad ground in these lighting circuits, particularly on cars that aren't all that new? Basically, that's going to be that little socket. You know the little sockets that cost about $8 or $10 that you sell? Those sockets go bad. And that'll be a bad ground. That socket won't be grounded. The wires are still hooked to it, but something inside of it goes wrong, and the ground is no good anymore, and you'll turn on one light and other ones will come on. Like there's one bug I can plant on one of these cars out here, that when you try to start the car, the wipers run all the time, and the scan tool won't talk, and it won't start. And it's one teeny tiny little ground wire that's real easy to get to. Some of y'all might remember me planting that bug. It'll drive you crazy trying to figure that out. All right, if you don't think clearly, if you got a bunch of other stuff that fires up when you turn on this, look for a ground problem. Look for common grounds, common connectors, common power sources. Common grounds are really important. But I'm fine. What do these things have in common? Do they all pass through the same connector, the same pin? Do they have the same common ground? Do they have common power? Whatever they've got in common is where your problem. If I'm seeing several things that aren't working, and I say, okay, all of these are grounded at G103 at the front left fender or whatever, and I'm going to go over and I'm going to see that thing is loose. You see, and if I feed a ground in there, you know, with maybe my jumper wire or something, and this thing cleans up its act and it does like it's supposed to, then I know I've accomplished my objective. I had a Mustang one time that had 2 amplifiers on it. It was a brand new car, had amplifiers in the back for the sound system, some super duper whatever, and none of the speakers on the left side would work, but everything on the right side worked. And I looked at the schematic, it had 2 amps, it had 2 whole systems wired up, and it had 2 grounds. And I went behind the kick panel and I found that ground just a flopping. Put a screw in there, now we got music everywhere. You see what I'm saying? But you had to look and say, what does this have over here and that's different from what that's got over here? Is it possible for that one to have its ground and power and that to be missing one? And that was what was the deal was on that. I'm moving pretty fast here, but y'all need to absorb this. And it'll be available later to look at on YouTube if I'm going too fast for you. Okay, now we're looking here. We're down to 15, right? No. Which does not control the brightness of the instrument panel lamps. Diodes, rheostats, pot, None of the above. And basically, A is diodes. Potentiometer will in some cases, because you'll have some electronics in there and you'll have a potentiometer instead of a rheostat. Again, what's the difference between a potentiometer and a rheostat? A rheostat pulls a load, a potentiometer sends a signal. Got it? A rheostat pull. This thing right here, see if I got this little knob here I could turn that. This thing here is actually pulling the headlights, I mean the instrument lights going through there. This right here is a potentiometer, you know, throttle position sensor. It sends a signal, but sometimes your headlight switch will have a little thumb wheel on it, and it'll actually be a potentiometer that's sending a signal to another box, and that other box is reading that signal and brightening and dimming the lights. And sometimes you'll have power transistors, like on some mid-80s Camaros and stuff that operate the dash lights that have a little potentiometer feeding them. Okay, let me see. What are the non-electric turn signal flasher units acting like when they supply rapid on-off current flow? What? Non-electric turn signal flasher units to the turn signal lamps. That's 15. That's A. I'm not even going to go there because I'm going to tell you the truth. I don't know what the Sam Hill are talking about when they say non-electric. Wow, pretty amazing. Unless they're talking, no, non-electronic. Okay, never mind. That's the little round silver can with the two wires. That's non-electronic. It's not non-electric. I read that wrong. Non-electronic, it's got a little bimetal in there. And bimetal's got two kinds of metal married to each other that are expand and contract at different rates. And when you put heat through there, it goes ding, ding. And whenever it opens up, it cools off and it closes. And it happens really fast. If you ever pull one of those apart and watch it work, you'll see that little thing moving back and forth. Every time it makes a connection, it heats up, it breaks it. It's like a circuit breaker. Except it happens real fast and is designed to work for a long time. Okay, Technician A says replacing a composite headlight bulb. It's okay to touch a glass envelope with your fingers. That's actually the little halogen bulbs like I was talking about a while ago that I said don't touch with your fingers. And basically, Technician B says when replacing a composite headlight bulb, extreme care must be taken so as not to touch the glass envelope with your fingers. This is a lot of candy for a nickel there. That's B. That's going to be, you don't touch it with your fingers, okay? There's like these quartz lights that go in these, 120 volt. If it's got quartz and it's a quartz halogen light, you don't want to touch that because it won't last no time. It'll just blow right back out. Technician A says diodes are used in a center high mount stoplight for proper turn signal operation. Technician B says diodes are used in a center high mount stoplight to prevent radio static when the brake light is activated. That's basically A. But they don't all have diodes. Like some of them have got the total separate, they got discrete circuits. And that's D-I-S-C-R-E-T-E, not E-E-T. And what that means is it's a separate circuit that's feeding that light than it is that's feeding the other ones, like I was talking about earlier. And you see what CHMSL is? C-H-M-S-L. What does that stand for?
Oh, center high mount stoplight.
Center high mount stoplight. If you look in that GMC out there, if you look at that little legend for your fuse panel, one of those fuses says C-H-M-S-L. You got me? And that's center high mount stoplight. Chrysler and GM both use that same acronym. It's not really an acronym because they don't spell a word, but Ford I don't think uses that. I had never seen them use it, but Chrysler and GM do. What are the only white lamps allowed on the rear of a car?
The brake or backup lamps and the license plate lamps.
Yeah, it's basically backup lamps. And if the license plate lamp the lens has been painted and has dust all over it, you will not have a license plate lamp and you will get stopped and get a ticket. Okay. Technician A says an LED brake light illumination time is much more than a conventional incandescent bulb. No, it happens faster. Technician B says LED lighting has an extended lifespan when compared to standard bulbs. Who is that? That's C. Basically, a lot of little lights in there. Some of them may go out, but enough of them will work to keep you going.
Did you say C?
Huh?
Did you say C?
Yeah, basically C. Yeah. Well, no, wait a minute. Excuse me. That's not right. It's not going to take as long to light. Yeah, they got a wrong answer key thing there. That's what's going on there. You're right. A good catch, buddy. That's supposed to be B. That's supposed to be B only. Extended lifespan. It doesn't take longer to light up. LEDs are instantaneous. Now then, these are the short answer questions that everybody loves. I ought to just do all of these on your final, shouldn't I? You like that, wouldn't you, Joe?
No.
Okay. What are rheostats or potentiometers used to control in the instrument panel? Did I miss 20?
Yeah.
Oh, you're right. I actually jumped over that one. Which of the following best describes the function of the bi-xenon system? Yeah, that's a crazy thing, isn't it? One chamber's for low beam, both chambers are ignited for high beam. That's what that is. No, it ain't. What is it? Is it a chamber filled with multiple xenon gases that are ignited at different temperatures? When today's technician performs repairs on the lighting systems, the repairs must meet at least what two requirements?
They're gonna work.
They got to assure vehicle safety and meet all applicable laws. You're also supposed to know when to turn your lights on. You know, in Texas, they say you're supposed to turn your lights on if you can't see clearly for 1,000 feet. You got me? All right, so here's funny. How does a lamp produce light?
Resistance?
Huh? How does a lamp produce light?
Is it resistance? Or
Well,
is it-
you're actually allowing current to flow through a filament. Basically, you're similar. I mean, the filament's got to be able to, the filament has got to be so that it's isolated from oxygen. When you put halogen gas in there, it burns brighter, but it doesn't burn up. See what I'm saying?
What about xenon, where it's got an arc?
Yeah. Well, that one's a different kind of light, and that doesn't. This question doesn't apply to that one.
Oh, okay.
But they wouldn't call that a lamp, I don't think. I mean, that may be the little disclaimer you have. That's not really a lamp. It's called something else. But you're making a good point. Most vehicles that are equipped with an automatic transmission incorporate the backup light switch function into what other switch?
The gear selector?
Neutral safety switch, yeah. And you're on the right track, Lundy, when you say that. Okay. How do the headlamp lenses redirect the light beam and create a broad, flat beam?
Prisms?
Prisms, yeah, it's got prisms in there. Very good. What switch allows the driver to select either high or low beam headlamp operation? Duh. Dimmer switch. And the vehicle's lighting system's controlled by a headlamp switch. And here's another little deal. You know, the people come in here. Once somebody comes in here and they say, none of my park lights work, but my headlights work just fine. What's the first thing you're going to do?
The headlights work, but the parking lights don't.
That's right.
You said check this ground.
Check the switch.
Well, let's go easy and quick first, y'all. Switch is hard to get to, huh?
Check
The switch is working because
Well, all of them I'm talking about are dead, huh?
the switch is alright because one of the lights come on, but you gotta check and see.
Well, now, wait a minute. Didn't I just tell you that there's two different parts of that switch that operate the headlights and the tail lights? You know, there's a different power coming in and a different power going out for different power coming in typically, and a different power going out for the headlamp, and than it is for the tail lamps. So if my tail lamps ain't working, the first place I'm going to go is to the doggone tail light fuse.
tail lights, check the ground.
Now the dash light fuse is wired in such a way to where it's downstream of the tail light fuse. Have you noticed that? If you blow the fuse going to the dash lights, you will not lose your tail lights. But if you blow the fuse going to your tail lights, you will lose your dash lights. And the reason they do that is so you'll know there's a problem with your tail lights. If your dash lights are out, people are not going to like that much. You get me? You're looking perplexed, Willie. What's up with that?
No, because the dash lights on my Ranger's out,
Oh, no.
but the tail light's not out.
Yeah, well, you've got a different fuse. There'll typically be a 15 amp fuse that's feeding the tail lights, and branching off of the circuit feeding the tail lights, there'll be a 5 amp fuse feeding the instrument lights. Now, I'm not saying that every time your instrument lights are out, your tail lights are going to be out too.
No, because it could
But,
just be a bulb.
yeah, well, a bulb, you got a bunch of bulbs in there for instrument lights.
Yeah.
So basically, you know, and what I'm getting at is don't go and do what's the hard stuff first. You know, I can say, well, I'm going to go look at the headlight switch. That sounds good, but let's check the fuse first. And I don't know how many times I've even gone to where I thought the problem was and found out crud. All I had was this other thing. Like, for instance, you find something that's a particular circuit on a car that feeds a bunch of stuff, and I find out after I've gone to all this trouble digging around all that kind of stuff that I had a shorted cigarette lighter. You know, the cigarette lighter element, and somebody plugged it in, pop. This girl a while ago came out here that has got that car that's supposed to have the tow set. No, it's not a 300, it's a Charger sitting out there. And she says, my little cigarette lighter power point hadn't worked in a long time, but now the one in my console's gone out. This is the weirdest thing that I'd seen in a long time. The fuse was good for the one in the console, but it had a penny in it. Now, what does that usually do? A penny had rolled down in there. It was in the console. It usually blows a fuse, but on that one it didn't. It was apparently made so that penny kept her from getting power with her little charger, but she didn't have any problem with it blowing a fuse because the fuse was good. You know, as a matter of fact, I even stuck the test light down in the center of it and read power down in there because I guess I pushed it a little harder than her little spring-loaded nose on her thing. But anyway, when I pulled it out of there, everything worked really good. And her other thing, she had the fuse plugged in the wrong place. All right, so anyway, let's go into that. Let me see here. Explain steps to be taken before replacing headlights. In other words, if a headlight doesn't work, and before you throw a headlight at it, what do you need to do? Now, I'm going to say this. Typically, if a headlight don't work, what is it most of the time? It's a bulb. Usually it's a bulb. You know, about 29 times out of 30 it'll be the bulb. Well, the other time it's going to be you're going to put a bulb in it. It's going to be, and usually you can see what's wrong with a bulb. But I mean, looking at the bulb's a good plan. But you know what they're telling to do is use a voltmeter or test light to confirm voltage is present. Well, open circuit voltage is going to read on your meter, but I want to know if it'll burn a test light. Check the ground for proper connection, and if required, perform a voltage drop test, both the power and ground circuit. Okay, let me ask you this. How would I do a voltage drop test of the headlight circuit? I need a quickie, guys. Something quick and easy. Ain't going to take you long.
The same side as the power.
Why don't I take the positive, we're going to go to the most positive part of our circuit with our test light. And we're going to touch that to the positive battery terminal. It's, you know, the GM ones that have the side posts, I don't really like those because there's not any way to get actually to the battery terminal, you know, because you got that rubber and then you got that little, but if you can go right to that positive post on that battery, and I'm going to start there, and then I'm going to go with the other part of my meter to the doggone headlight filament that I know I'm checking. Like if it's got a green wire with a black stripe and that's your bright headlight, you know. So yeah, when I'm going to turn on my lights, dunk, and I'm going to hook my voltmeter between the positive battery terminal, and I'm going to go in, I'm going to back probe that headlight, you know, bulb, and I'm going to read what's there. And if that headlight's dim, or let's say that the headlight's completely out, and I'm reading 12 volts there.
It means it's on the negative side.
Means we're dropping everything. And that's why the light's out. Because you're going to read, when you go from positive to positive, and you read voltage, right? That means that between there, you're dropping whatever you're reading on that meter. Now, if let's say that light's dim, and I go from here to there. Now, let me ask you this. Why don't I go from the negative side, and I go to the ground wire that goes into the bulb? It's usually black. It's usually pretty easy to see. I turn on my headlight so current will be flowing. That's going to tell me if I've got voltage drop on the ground side or if I got a bad ground totally. Because if I got a totally bad ground, I'm going to read 12 volts there, right? Everybody understand that?
Yes.
You can do voltage drop tests on just any circuit that carries current. And a lot of times you can find a problem that nobody else can figure out. Now what a lot of people will do is they'll put straight power in there to see if it burns brighter, and then they'll know they got a problem. They got to go find that way. But if you get you some numbers, and your boss man says, how in the world did you find this? You say, I did a voltage drop test on the headlight circuit. And most of them are going to go, say what? You know, because who does that? But it makes sense to do it. You see what I'm saying?
Mm-hmm.
A lot of times you may come up with something that nobody else does that works better than anybody thinks it would. And I've come up with a bunch of stuff like that, you know. I've had people pay me to build them little test boxes and stuff, you know, because I always build mine. You know. All right. Now then, number 32, describe the procedure used to test non-electronically controlled turn signal circuit. Easiest thing in the world, guys. Use a jumper wire to bypass the flasher. It's a little 2-prong can flasher. If you jumper wire it, it's not going to flash, but you're going to turn it to the left. You're going to see that light come on solid. You're going to turn it to the right. You're going to see that light come on solid. If that happens, you'll know that the flasher's bad. Word to the wise. If you've got one side that just comes on steady and the other side that flashes, is it possible for that to be the flasher on one that's got the little silver can? Everybody's quiet. Okay, I'm turning on my right turn signal and it comes on solid. Doesn't flash. I turn on my left turn signal and it flashes.
There gotta be the flasher bulb.
Pardon me?
The flasher bulb, the bulb, I mean.
The bulb, no, they come on solid.
For both sides.
I thought you said one flash.
One flashes, and they turn it on, the other one doesn't. Can that be a turn signal flasher problem?
I don't think
Because
so.
for the left and the right, it goes to the same flash.
It sure does, yeah.
Yeah, so it's gotta be the.
It's gotta be something that
turn
passes
signal
that.
bulb.
Yeah,
Is it a shorted bulb?
99 times out of 100 you're right, but I've actually seen one on a 79 Dodge truck, and it was chocolate brown, and it was a step side, and it had a 318 in it. And I turned on the right turn signal, it came on solid, and the truck wasn't all that old, and I turned on the left turn signal, ting, 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 ting. And so, I wonder if I could change a flasher and fix that. So I popped another flasher in it and took care of it. And it doesn't make sense. I don't know why. Unless there was a little bit more voltage drop on that right side, and a lot of the older flashers required a certain number of bulbs before it would even flash. You know what I mean? Some of those silver flashers, if it was actually designed for 2 lamps, and if only 1 lamp was blown, it wouldn't. I mean, but that's that's all moot. That's old stuff, old technology. What's the center high-mounted stoplight, and what year was required to be installed on passenger vehicles?
86.
Starting in '86, vehicles, passenger cars, were required to have a center high-mount stoplight. Now, I've talked about this before, but if the center high-mount stoplight is inoperative, you are 40% more likely to be rear-ended by another car. And if you forgot to check the center high-mount stoplight because you didn't think it was important, and then somebody gets rear-ended, and they find out you just did an inspection on the car, and the center high-mount stoplight wasn't working, and they could probably say that you indirectly caused that crash if they wanted to push it. Keep that in mind. Do not forget that. Now, on some center high-mount stoplight systems, on some, we got it. What's the purpose of the diodes? They don't want it to flash when you turn on the lights and all that. I mean, this thing's got a long answer, but you don't need that. Explain the causes of dim lights. What are we again?
Ground.
Well, excessive resistance either on the ground or the hot side. What about alternator output? Wrong lamps, improper circuit routing, extra electrical loads, wrong size wires. Got that? Excessive resistance, low alternator output, wrong lamps, improper circuit routing, or extra electrical loads, in other words, other stuff loading that same circuit, or the wrong size wires. And then finally, number 36, and we're just right on time. LEDs are light-emitting diodes that have a shorter illumination time of about 30 milliseconds. And they also got a longer lifespan compared to a standard light bulb. That's the last one. Okay, that was kind of long. Now over here on this other table,